What's up, everybody? Today we're going to be doing the Cambridge IGCSE Additional Mathematics Paper 2 Variant 2-1 for the May-June 2023 series. Alright, so without further ado, let's begin. Question 1. Variables x and y are such that when given log y is plotted against root x, a straight line, okay, pass through the points 1, 5, and 2.58. So show this where a and b are constants to be found. Okay, so we know that this is going to be linear law, therefore, and we're already given log y and root x. These two are plotted against a straight line to give these 2 points. So we know that in a y equals mx plus c graph, where in this case it's a log y against a root x graph, it's a straight line, we need to find the gradient of this straight line. So that's what I did. Gradient m. As you can see, I wrote, this part right here, we found the gradient. And, okay, once you find the gradient, the next thing you want to do is rearrange it so that you can get the equation of the log y against root x graph, which is in straight line form. So there are 2 ways to do it, because if you want to show, this equation right here, y equals to a times b to the power of root x, you have to get the straight line equation of the log y against root x graph first. Then rearrange it to make it, just move the log to the other side so that you can get a times b root x, b to the power of root x. So what we need to find next is the equation of the straight line. And there are 2 ways to do it. One way is to use the y minus yi equals m x minus xi method. This is a formula to find the straight line of a graph. Or the other way, method 2, is to, find the y-intercept, the very conventional method of finding y equals to mx plus c, where we have to find what c is. But this method, method 1, uses this yi, yi and xi, which is just any point, yi and xi being any point on the straight line. So you can just use any point on the straight line. In this case, I used 1 and 5. So yeah, and we know that since this has already been linearized to log y against root x, we can just straight away write log y minus 5 equals to 2 times root x minus 1. Instead of writing, log y as y, because it kind of is, it has already been linearized into log y. So we can just straight away write log y to get the equation of straight line, which is going to be in this form. So from this, we know that the y-intercept is going to be 3, right? Because now it's in the form of y equals to mx plus c, right? So we know the c is going to be 3. But that doesn't really matter in method 1 because we don't have to find the c. Because technically when we use this method, yi and xi method, this equation right here, we already found the c. So, okay, enough explaining. When you further simplify it, you're going to get this, which is what we want. Now that we remove the log, we can now simplify it further. And what we get is going to be this, which is the answer, a times b to the power of root x, right? And so for method 2, it's a slower method, but I would still recommend you to use it to check your answer. So you find c, and we know that, log y equals to m root x plus c. It's in the form of y equals mx plus c, and we know that 1, 5 is a point on the line, so we can just find the equation of, we can just find the y-intercept, and we found that the y-intercept is 3, and now we can write this back in the form of y equals mx plus c right here, which is log y, because we already linearized it to log y and root x, so we have to write log y equals 2 root x plus 3, then same steps to method 1, and you get a times b to the power of root x. So same way to do it. Alright, 2 methods. I recommend doing method 1 when you're doing it for the first time, but when you're finished with the paper, do method 2 to check your answer. Alright, question 2. So the function g is defined for 0 to 120 degrees by gx, which is this function right here. On the axis, sketch the graph of y equals to gx. So I wrote here, gx is equals 2 plus 4 cos 6x. We know that this is in the form of a plus b cos kx. So there are three things you need to find in order to start sketching y equals to gx, or for any trigo functions, to be honest. Except for this does not really apply for tangent graphs. Tangent graphs are a little bit special. But for sine and cos, yeah, that's the same rule applies. So first thing you need to determine is the period. Or actually, the order here of what you find first really doesn't matter, but you have to find these three things in order to start sketching. So the first thing I found is the period, and the period can be found by, 360 degrees divided by k, where k is, in this case, 6. I wrote it here in this form, so you just need to reference it from here. And the reason why we divide it by 6 is because what was originally a cos x graph has now been stretched to a graph to give cos 6x. So what this means from cos x to cos 6x is that the graph has been stretched, by a scale factor of 1/6 parallel to the x-axis. So that means the period is also, divided by 6. It's now 6 times smaller than it previously was, because now it has been stretched by a scale factor of 1/6. So, just some transformations, I mean, everything here is just a transformation from cos x. This right here is a stretch parallel to the y-axis. This here is a translation, by 2 units up, and so on. So yeah, everything here is just a transformation from cos x. So anyways, moving on from question 2. Okay, so the second thing you need to find is the line of symmetry. In this case, it's a, which is equals to 2, right here, line of symmetry. And the next thing, or the last thing you need to find, is the amplitude, which in this case it's b, which I wrote as 4. In this case it's 4. So although this may be the amplitude, you need to know that that's not the range of the gx graph. The reason why it's not the range of the gx graph is because you're missing a 2 right here. You have to add 2, and also, bear in mind that you have to add 2, and also, which is right here, 2 plus 4 and 2 minus 4, which gives us the actual, you could say, range of the graph. The amplitude is 4, but that's not the range of the graph. Sometimes you might be wondering, like, you're given like a 4 cos 6. If you're given 4 cos 6x, then yes, the range of the graph is between 4 and -4. But that's because there's a plus 0 in front. We don't need to write a plus 0, although it's not wrong, even if I write a plus 0. But to simplify things, we don't write the plus 0. Therefore, the range of this graph can be between 4 to -4. But in this case, we have a plus 2. So actually, the range is not just, 4 to -4, but 2 minus 4 to 2 plus 4. In this case, it's between -2 to 6. So that's the true range of the graph. So once you get all the details, you can start sketching the graph. You know that the period is 60 degrees. So that means between 0 to 120 degrees, there's going to be 2 of these graphs. And yeah, you sketch it out. The line of symmetry, right here, y equals to 2. Oops, let me just maybe arrange it properly. So yeah, y equals 2. You don't have to draw this red line. But yeah, that's the line of symmetry. And you're just going to draw it for reference, so that's easier for you to draw. All right, so oh yeah, also for a cos x graph, you need to know that the shape is going to be like this. Original cos x graph will always look like this. If it's a negative cos, then obviously it's just going to be a reflection against the x-axis. So everything that was once up has to be flipped, Anyways, state the amplitude of g. The amplitude is 4, as I already, mentioned right here. And what the period is 60, so it's 360 divided by 6. So easy questions, easy marks, because you've already done it on 2a. Okay, question 3. The diagram shows the graph of y equals hx, where hx is this equation, and a, b, c are integers. The curve meets the x-axis at these points, and y-axis at, 0, 12. So find the values of A, B, and C. This question is, I would say, probably the trickiest one in the whole paper, in my opinion. So we know that, x plus A, B plus CX are factors of HX. So ignore my answer here because I want to explain my method of solving this further. So, okay, we're given the points, this and this right here, right? -2, 0, 1.50, and 0, 12. So, and we know that these points, -2, 0, and 0.50, are actually the points that, intersect the x-axis. Therefore, these 2 points are actually the roots of y equal hx. Therefore, we can say that -2 and 1.5 are actually the factors of hx. And when we know that, hx, let me use a different color. We know that hx, equals to x plus a squared b plus cx equals to 0, right? And when this happens, we know that the factors, in this case, the values of the factors are -2 and 3/2, or 1.5. So from that, we already know that, the factors are going to be -a, and x equals to -b/c, right? If you were to find the roots. And so from here, we know that, okay, since x equals to -b/c is in the form of a fraction, that means this 1.5 or 3/2 must belong to this one right here, and this one, -2, 0, or -2 as a factor, must belong to this one right here, must belong to this x right here. So we know that, from here we can do x equals -a and a equals to 2. So that's how you find a equals to 2. Now the tricky part is finding what b and c is and where the sign goes. We know that, it is going to be 3/2 equals -b over c. But here's the tricky part. What are the values of b and what are the values of c and what are their signs? This is the tricky part. So if I were to rearrange it, the way I did it, if I were to rearrange it, it's going to be in the form of cx equals -b, right? And we know that the c has to go over to the other side. So first, we determine what the value of c and b is. And after that, we determine what the sign of c and b is. So first, we determine the value. We find the value, and in this case, c is going to be 2, and b is going to be 3, right? Because the only way for you to get 3/2, the absolute value, let's just say absolute value, which is 3/2, is going to be c equals 2, and this part be either -3 or 3, right? It doesn't really matter. I'm just finding the value, not the sign yet. So x can be equals to 3/2, which is equals to 1.5, you know what I mean? I hope you understand what I mean, So this is -3. Whether it be -3 or 3, I don't really care about the sign right now. I'm just caring that b is a 3 and that c is a 2. So when I divide it, it becomes 3/2. Because if I were to do it the other way around, this being 3 and this being 2, it would be 2/3, which is not a factor, right? The factor is 1.5, which is 3/2. So yeah, so we know that the values of c and b, c will be 2 and b will be 3. Now the real question, or the tricky part, is what is the sign of c and what is the sign of b? We know that c is going to be 2, but is it -2 or, +2? And same for b. Is it going to be 3 or -3? We don't know, because if you were to, look at it like this, cx equals -b. If b is -3, if b were to be -3 and c were to be 2, you can get 3/2. But it can also be, if c is -2 and b is 3, b is 3, then you would still, if c is -2 and b is 3, it would be -3, right? Because multiplied by negative. So this would still be 3/2. So there's actually no way of determining what the sign of c and b is. So the trick is that we have to use the y-axis, or the y-intercept, which is 0 and 12, right? So we have to use 0 and 12 to figure out what the sign of B and C is. We know what A is. A is going to be 2. So we confirm A is going to be that. A equals to 2. So the way you figure it out is just substituting 0, 12 into hx. So x is going to be 0 in this case. So we know that h0 is 12, right? But you have to write it out. So it's going to be like this. And we know a is 2, right? Squared multiplied by. So b plus, here's the trick. See? 0 multiplied by c is just 0, right? So you get 12. Therefore, it's going to be 4b equals to 12. So from here, we know that b must be equals to 3 in order for it to be 4 times 3 equals to 12, because 12 is positive. Therefore, the negative must go to c and not b. And that's how we determine the sign, right? I know this might sound a little bit tricky, but yeah, that's how you figure it out. So the b must be positive. Why? Simply because if you substitute the point of y-intercept inside of hx, cx, where x in this case is 0, is going to be 0. So it's going to be what you're left with is 4b. And 4b equals to 12 forces b to be 3 in order for the condition to suffice. Therefore, the graph must be having a b that is equal to 3 and not b equals negative 3. So from here, you can determine that b equals 3. So you can confirm that c has to be negative 2 in order for the factor to be 1.5. And that's how you figure it out. Okay. B, use the graph to solve the inequality. So use the graph hx less than or equals to 9. So what I did is just draw, a dotted line at y equals to 9. And then I drew vertical lines at the point of intersection at y equals 9 for this graph, and referenced it from the x-coordinate, from the x-axis to find the x-coordinate. So we figured out that, for h equals to 9, it's between this region right here, this whole region. So it's everything in this region. It's between negative 3 and 0.5. So that's how I figured it out. And the same thing for here. The next intersection point is over here. So we figured out, hx less than equals to 9. Everything over here is less than 9. Less than or equals to 9, which is all the points that are x greater than or equals to 1. So, and that's how I figured out. So it's going to be negative 3 between negative 0.5 and, x greater than or equals to 1 in order to figure out how to get the inequality for hx less than or equals to 9. Okay, so yeah, question 4. Solve the equation giving your answer to 3 decimal place. So pretty straightforward, just, logarithms. So just, follow along. 5 equals to 5 to the power of 2, 5. You get 5 to the power of 2 minus 2y minus 1 equals to 6 times 3y. If you take out the, this part, which is 5 to the power of negative 1, I wrote, multiply it outside. This is technically, this part right here is 5 to the power of negative 1. I just took it out so that I can rearrange it properly. So 25, power of y. Since this is a multiplication, you can do division, divide it on the other side, and now you have y on both sides, and you have integers on 2 sides. So now that you clean it up together, you can take logarithms to make it like this, so that y comes out, and move it to the other side, so that, this logarithmic part can be divided over here. So it's pretty straightforward. Not much I can really explain. It's just algebra, really, with techniques of logarithms. So you just need to know, I would say the way to get better doing this problem, these type of problems, is just by doing more, because then you just have a vision of how to do it. I don't really know how to explain how to spot it. You just gotta do more in order to figure out that, oh, actually I have to, you know, move this 3x over here on the other side so that I can have y on one side and not on both sides, and turns out I can actually take this 1/5 to the other side as well, and I can solve it just like that. It's hard to explain, but basically just do more of these type of questions and you'll figure it out. And obviously don't forget 3 decimal places, round it to 3 decimal places. All right, and then next thing is just solve the equation. Again, pretty straightforward. In exact form, don't forget. So this is actually just a quadratic if you look closely. You could, if you're not familiar with it, just let y equals to e to the power of 2x. And then this would just be what? Y squared minus 4y plus 3, But you don't really have to if you can spot it. So again, it's just a quadratic, solve the quadratic. Then you've, e to the power of 2x is equals 3, to the power of e to the power of 2x is equals to 1. Take ln on both sides. Then you can get the exact value in exact form. Yep, and that's 4 marks. Easy. There's, for these type of questions, it's, for this whole question, and to be honest, there's no, variable method to do it. It's pretty straightforward. It's just like one method to do it all the time. I can't really show different methods to do these type of problems because there's really only just one way to do it. So if you don't know how to do it, you're done for. But if you know how to do it, it's 3 marks, really. All right, question 5. So the volume V of a sphere, radius r, okay, there's a formula of a sphere. The volume of a sphere is increasing at a constant rate of 24 cm³ per second. Find the rate of increase of radius when the radius is 6 centimeters. So, okay, the details we were given is that the rate of increase of the volume is dv dt, which is dv dt is equals to 24. And we're given that the formula of this volume of sphere is 4/3 power cube. And we want to find the rate of increase of the radius, which is dr dt. So to find dr dt, as I wrote here, it's equals to dv dt multiplied by dr dv. And we know that dv dr, once you differentiate this, you get dv dr will be equals to 4 pi r cube. 4 pi r squared. So this implies that dvr dt is equals to 24, which is the value of dv dt. I just substituted in, and 1 over 4 pi r squared. Why? Because this is dr dv and this is dv dr, so you actually have to 1 over 4 pi r squared. You have to put a 1 over. And simplify it, you get this. Substitute r equals to 6, which, they already gave us. Find the rate of increase of the radius when the radius is 6. So substitute that in and you get this, which is around this value, 0.0531. Rounded to 3 significant figures. Always remember, rounded to 3 significant figures. Very important. Don't write more than that. It's just a standard way of calculating or writing your answer in all additional mathematics papers. All right. This question is also pretty straightforward. So, question 6. The position vectors of the points P, Q, and R relative to an origin O are these, okay? Respectively, the point R lies on PQ, extended such that 3QR equals 2PR. Use a vector method to find the values of X and Y. So this question actually is very simple, but although it may be simple, there are tons of ways to do it. For me, I found 3 ways, and I will show you the 3 ways to do it so that you can check your answer. Although it may be simple, questions like these, are really easy to lose marks, because if you think it's simple, sometimes you just rush through it without ever thinking whether you did it right or wrong. But it's really important to know multiple methods so you can check your answers, because this question can be solved using, at least to me, I know 3 methods to solve it. So we'll go through the standard or the method that they want us to use, which is the vector method, to find the values of x and y. So method 1, I use the vector method, which you find what QR and PR is, the vectors of QR and PR, and you found that they are these two values right here, and you are given that 3QR is equals to 2PR. So all you need to do is just substitute QR, the vectors of QR and PR, substitute them in, then make comparisons to both equations on both sides, and you can get x equals 16 and y equals to 1. Very straightforward, I know, but I want to show different methods so that you can check your answer to make sure that your answer is correct. So method 2, or maybe, who knows, they might ask you to use a different method and not a vector method, right? So this way, I'm using the coordinate geometry method, which is this one is probably the most troublesome one, and I hope the exam doesn't and never ask you to do this, because I'm too lazy to even complete it. There's just too much work. But I'll just explain the idea and the approach to how to do this problem. So first, define what PQ is. I mean, they already defined it for us. So we just have to set it again. Let L be the line containing PQ and R, because again, they say R lies on PQ. So you can think of PQ as a line. So I just, let L be the line containing PQ and R. So we find what the gradient is, because we already have 2 points. We can find the gradient, and we find the equation of L. So we're given that, 3QR is equals to 2PR. So what this implies is that the distance of QR, 3 times the distance of QR is equals to 2 times the distance of PR. So this is what it implies as well. So you can write that as an equation, distance formula. So I wrote this as equation 2. So yeah, and once you get these 2 equations, you can solve the equation. So substitute y equals to, substitute 1, which is negative 1 over 2x plus 9 into 2. Substitute that in, find what the value of xq is. And once you get the value of xq, substitute that value of x2 into into 1, the first equation 1, to get yq. And that's how you get, and then you'll get x equals 16 and y equals to 1. It's just another way to do it. Not recommend you to do this. What I would recommend you though to use to solve this problem or to perhaps check your answer is method 3, which is the ratio formula. So this method is really useful. My personal preference, I love using this ratio formula to solve problems, especially for coordinate geometry. And yeah, I'll explain it to you how to use it. So, okay. First, I drew a sketch of it, P, Q, and R. And I wrote the coordinates of these points. I defined them as well as X, R, Y, R, X, Q, Y, Q, and X, P, X. Oh, wait, hold up. X, P, Y, P. Oops. X, P, Y, P. Okay. So, yeah. So I defined the points on this line. Then we're given that 3QR, the vector of 3QR is 3 times the vector of 2PR. So what this implies is that QR is 2 over 3 of PR. And so this also implies that the ratio of PQ to QR is 1 to 2, because if you have to be good at visualizing ratios in order to do this. It's really important to be able to visualize it. So once you visualize it though, it becomes really easy to solve. So we know that, okay, the ratio between QR and PR is 2 to 3, right? And this is between PR and QR, right? And we know that this is 3 to 2. So we need 3 QRs in order to suffice or be equivalent to 2 of PR. Therefore, if we were to split it out, we would get 2 of PQ is equals to 1 of QR, right? I hope that's easy to understand. I hope you can visualize it, because that's it's really important to be able to visualize how to do this one. You have to be able to know what you're doing. So with this method, if you're not familiar with ratio formula, I would still recommend you to try it and master it if you can. But if you really just can't do it, then it's okay. But definitely you should try it out if you can, and try to learn it if you can. So if you go, okay, so now we know the ratio of PQ to QR, which is 1 to 2, and I define them as N and M, so where M is 1 and N equals 2. So using the ratio formula, the coordinates of Q will be this. I wrote down the formula so that people that want to learn can understand how to use the formula. And the next step right here is just the substitution of all the values, and when you solve it, you can get what XR and YR is. And then, yeah, that's going to be the final answer. R equals 16.1. And that's how you solve it. So, yeah, this question has 3 methods. Method 3 is probably the hardest to figure out, because you have to be good at using ratios, and you also have to be really good at imagining what's going on for the points between everything in this line that contains P, Q, and R, to be able to differentiate the ratios between everything. It's really hard for me to explain why it's like this, like 2 PQ to QR, because you have to be able to visualize it. So maybe just stare at it longer and just think about it, and I'm sure you'll figure it out. All right. Yeah. Okay. So 6b, you are given that and also, if you don't understand what I'm saying, I'll try my best to reply to you. Just leave a comment in the comment section. So I'll reply to you as fast as I can to explain to you, what you don't understand. Okay, anyways. So 6b, you are given that I is a unit vector due east and j is a unit vector due north. Okay, so 3 vectors A, B, and C are in the same horizontal plane, and the magnitude and bearing are 5 and 210. Magnitude and bearing C are 10 and 3 0. Okay, so this is pretty straightforward. Find what A and C is in terms of I and J. So I drew this diagram for you to visualize. So they said J is due north and I is due east. So, and we know that the way we measure the bearing is by measuring it from north, right? So if I want to find what, let's say, C is, or maybe the K, we have to measure it from north. This is north, so this will be the angle or the bearing of K. So it's always bearing is always measured from north, and so yeah, this is how I drew it. And okay, so let me go through this real quick. So we know that the vector A has this diagram right here, right? I is due east, J is due north, and we know that the bearing is 210 degrees. So what I want to emphasize on is that notice that in this line right here, in this region right here, it's 180 degrees. So what that means is that in this section over here, the one I colored, purple, that area or that angle is going to be 30 degrees. Why? Because it's just 210 degrees minus 180 degrees. So that's going to be 30 degrees. And same goes for here. Notice that from, when we go one loop over here, when we go 75% of a full loop, it's going to be 270 degrees, right? And we know that since the total bearing is going to be 330 degrees, and since we know this is going to be 270 degrees, this part is going to be 60 degrees. So yeah, that's what I did. So the purple part is going to be 60 degrees. And from that, you can start resolving your vectors to find what A and B is. So, okay. So now, to find A, we know A is in this direction. So therefore, the horizontal value is going to be, the horizontal direction is going to have a magnitude of 5 sine 30 in the negative direction. So you have to multiply it by -1. And in the downward direction, it's going to be 5 cos 30 degrees multiplied by -1. Why? Because it's going downwards. So yeah, that's what I did. And okay, if you don't know how to resolve vectors, real quick, this is data. Let's say this is some magnitude k, this line. If you want to resolve it into two components, x and y components, horizontal, vertical components, this, this length right here, the horizontal component, is going to be k cos theta. And this vertical component is going to be k sine theta. And the way you resolve it is whatever the angle touches if the angle touches this line, that means this line will be cos theta. And yeah, it's the other way around as well. If this is theta, then this will be cos theta, and this will be sine theta. So whatever the angle theta touches on the line, that line is going to be cos theta, and k cos theta. Otherwise, it's k sine theta. So that's how you resolve vectors. So that's what I did. You resolve the vectors, and you get this. And the same thing for C. So we know that C is 60 degrees over here. So it's in the left, or the north. It's in the north and the west direction, right? So west has to be negative. Why? Because we define J and I to be north and east. So since it's in the opposite direction, we have to multiply it by -1 when we go to the west direction. But since the upwards direction is positive, we don't have to multiply it by -1. So now that we know the direction, we just need to resolve the vectors, which the horizontal direction will be 10 cos 60, and the vertical direction will be 10 sine 60, which is what I did. And you have to multiply a negative. Why? Because this is going in the west direction and not the east direction. It's going against the direction that is defined, so you have to multiply it by -1. Yep. And that's how you do it. Okay. And all right, so find the magnitude and bearing of B. We're given, the question already gave us that A plus B is equals to C, the vectors. So we just rearrange it and solve it, and that's how you get B. So this is the vector of B. And once you get the vector of B, the way you find the magnitude is just it's just finding distance pretty much. So just use the distance formula, and you get 13.2 rounded to 3 significant figures. And to find the bearing, since bearing is measured from north, you have to remember that, okay, so again, I drew a diagram for you to visualize. So we know that this is -5/2, and this is 15√3/2. So we know that this is going to be in the west direction, and this is going to be in the north direction. So it's going to be somewhere northwest. So that's how I figured it out. So northwest, right? Northwest. So it's going to be somewhere in the northwest direction. This will be the resultant vector, which is B. And we know that the magnitude in the vertical direction is 15√3/2, and the horizontal direction is going to be 5/2. So what we need to find now, if we measure the bearing, is going to be from north until from north to from north to this, right? But the thing is, we don't know what this region is. So that's what we need to find, and the way we find it is by using trigo. The reason why we already know what this we already know that this region right here is 270 degrees, right? Because it already covered 75% of 360 degrees. So what we just need to find left is just what alpha is. So that's what I did using trigo. And 10 alpha is this, then you can get alpha to 3 significant figures. And that's how you get it. So the bearing would just be 270 plus 79.1. Rounded 3 significant figures, you get 349. And that's how you do it. Alright, question 7. So the diagram shows this curve, and you need to find the area of the shaded region. So this question is pretty straightforward. I define, let curve be C and the line be L. So the area of the shaded region would just be the area of C, total area of C between 0 to 5 minus the area of L. So integrate everything, and you should be able to get the answer 125 over 6. So over here, this part, for the straight line, you could use 1 over 2 base times height. I didn't use it, but you could use 1 over 2 base times height as well. But because we don't know what the height is, and I'm a little bit lazy to find what the height is, but you could also use height, 1 over 2 base times height, in order to find what the area of the shaded region is. Simple way to do it is just sub 5. We know what the hypotenuse is. We know what the adjacent is, right? We can just use Pythagoras to find this length and multiply it to the height. So that's how you do it. All right, BI. Pretty straightforward. These two questions, BI and B2, just integration really. Nothing much to explain here. So find the integral of these two integrals. So we just integrate. So this one is actually this right here is actually, you have to use one of the integral rules. Don't forget. Also, you have to note that cos x integrated is sine x and not negative sine x. So yeah, and once you integrate it properly, you should be able to get the answer, which is this. Negative 1 over 4 multiplied 2 minus x, 2x minus 6 squared plus sine x plus c. Don't forget plus c. And this one, find this integral right here. First, you open it up, take out, for me, you could choose to take out a 1 over 2 or leave it, up to you. I took it out, and you divide everything by x, you get, this right here, x7, x cubed, and 1 over x. Integrate this, and you get this right here. Don't forget that the integral of 1 over x is ln x. And obviously, don't forget a plus c. Multiply the 1 over 2 inside, and you'll get the final answer. So yeah, pretty straightforward. Just remember your integral rules, and you should be able to integrate everything. All right, question A. The diagram shows the graph of y equal fx, where f is defined by, this. Now, given that f is a one-to-one function, find the domain and range of f negative 1. So you need to note that the domain of f negative 1 is the range of f, and the range of f negative 1 is the domain of f. So it's just the opposite. So first things first, what you need to find is what the domain and the range of f is. And as you can see from this graph right here, it's already defined for us. The domain is between 0 to 3. And they already mentioned it, actually, 0 to 3. So what we need to find remaining is just the range of f. In this case, as you can see from the graph, if I were to just look at this graph, the graph that was given to us, we know that the highest point, the highest range is going to be at x equals 3, so that's what I did. So the range of f is just going to be between 0 to this value here, the equation of the graph, but I substitute x equals 3 inside, and you get 9 over 4. So that's the range. So this implies, it's just, flip it the other way. So the domain of f negative 1 is going to be the range of f, which is this, and the range of f negative 1 is just going to be the domain of f. And yeah, that's how you do it. So solve the equation. So for number 2, solve the equation. This is just algebra. Rearrange. You should be able to solve it. So solve the equation, when you get something like this, square both sides because you don't want to deal with the square root. And now it's just a cubic. You can simplify it out, and x squared is equal to 0. And these two right here, 5x equals 8, 5x minus 8 equals 0. Then you get x equals 0 and 8 over 5. So that's the answer. So that diagram above, on the diagram above, sketch the graph of y equals to f negative 1x. So this is just the inverse. So first things first, what I like to do is always to draw a y equals x graph, because that's, you know, where the if how would I say this? It's pretty much the point where the graph will be transformed against, you could say. So first things first, you draw a y equal x graph. Then from there, you know that if any point of the original y equal fx graph intersects with y equal x, then that means that y equals a negative, the f negative 1x graph, or the inverse of fx, will have to intersect at the same point as well. So this point right here, this is what I'm talking about. So at y equal x, it intersects fx at this point. Oops. So that means f negative 1x will also have to intersect at that point. So you can kind of use that as your reference point to start drawing your inverse. And also don't forget the range and domain of f negative 1x. It's going to be flipped. So the range is going to be between 0 to 9/4, and the domain, my bad. The range is going to be 0 to 3, and the domain is going to be 0 to 9/4. And that's how you do it. So when you sketch a graph, it would look like this, the inverse. All right. So that's how you do this part. Now you need to do B. The functions g and h are defined by this right here. Find an expression for the inverse. Okay, so I want to mention that I really hope, if you are doing this paper, you're not using the let y method to be equals to gx. This method is not really a correct method to find the inverse, because by definition it should be what I'm doing right now. This is the proper way to find an inverse. So we let u equals to the inverse, and g of u is equals to x. This is the proper definition. So basically it's pretty much just g of g negative 1x is equals to x. This is the definition. So this is how you solve it. This is the proper way to find an inverse, and not using the let y method. Although that's not wrong, but technically it's not right as well. This is the proper way to do it, the way I'm doing it right now. Let u equals to the inverse, and then gu is equals to x. Then you solve it, and you get u. Then this implies that u, because we already defined, u is equals to g negative 1x, right? So this implies that g negative 1x is just the inverse right here. This is the proper way to do it, the proper way to find an inverse, and the proper way to write it. I hope if you're using the let y method, I hope you can change it and use my method instead, because this is the proper way to do it. Don't use the let y equals to this and rearrange it and substitute y back into that value. So yeah. Number 2, state the least value of the constant k such that ghx can be formed. So for so we know that for gx, right, x must be greater than or equals to 1. For gx to form, x must be greater than or equals to 1. So that means since now it's going to be hx inside of it, now that we put hx, this inside of the x of gx, this part right here, we substitute e to the power 4x into the x of gx. This means that now e to the power 4x must be greater than or equals to 1, because that's a domain, right? So this implies that x will be greater than or equals to 0. And hence the least value of k will be 0. So that's how you do it. So, okay, find a simple, so 3 is just simple, like it's just substitute e to the power 4x equals to x, e to the power 4x into x, and you can get it. Simplify it and you get this 1 mark. All right. Question 9. So, in this question, all lengths are in centimeters and all angles are in radians. So the area of a sector of circle has a radius of 24 and a area of 432. Find the length of the arc of the sector. So let r be the radius and theta be the angle of the sector. I define, r and theta. And we know that, the area of a sector is 1 over 2 r squared theta is equal to 432. So substitute all the value that you have. We know that r is 24, so theta will be 1.5. And the arc length is just arc theta. That's the formula. So 24 multiplied 1.5, you get 36 centimeters. And yeah, that's the arc length. Question B. The diagram shows an isosceles triangle OAB with AOB equals to, AO equals AB equals Y and height AD. OCD is a sector of the circle with center O. Angle AOB is alpha. Find an expression for OB in terms of Y and alpha. So, this is just resolving vectors. So, yeah. Resolve a vector. So we know that if you don't know how to resolve a vector, it's the same thing again. So if this is alpha and this is y, whatever is in this length right here, the horizontal length, the horizontal component of y will be y cos alpha. And the vertical component of y will be y sine alpha. And the reason why it's cos, and how do you determine it's a cos and not sine alpha is just by figuring out that whatever the angle lands on to this, resultant line, if this alpha touches the horizontal component, then that means this component will be cos alpha. If it's the other way around, if alpha is here, then this part will be y cos alpha, and this will be y sine alpha. That's how you do it. So whatever the angle touches, the corresponding line will be cos alpha. So that's how you resolve a vector. And so yeah, OB equals to y cos alpha. If you can't figure it out, you could just, do the long way, alpha, then do trigo. So we need to find what, this length is. So you can do the long way. So we know, it's going to be, we have a hypotenuse and we know an angle. So yeah, then you can find out what the adjacent is by using what cos alpha is equals to adjacent A over hypotenuse. So it's going to be y cos alpha equals to A. And yeah, that's how you find the horizontal component, which is a longer way to kind of visualize it, but it works, I guess. All right. So we know that OD is going to be y cos alpha, but we want OB, right? And since this is an isosceles triangle, this part is going to be equivalent. OD will be equals to DB. So this is also going to be equals to y cos alpha. So yeah, the OB would just be 2y cos alpha, 1 mark. So now they say hence. So hence show that the area of the shaded region can be written as this. When they say hence, you have to use this right here, OB, the answer you found in BI. So again, the shaded area is just going to be the area of triangle OAB minus the area of sector OCD. So that's what I did. So 1 over 2 multiply base multiply height. Y sine alpha, I got it from what I said. It's just the vertical component. So this part, since the angle touches on this part, on OD, that means this part will be sine. So y sine alpha. This is the perpendicular height. So that's why I did. And then you minus the area of the sector, which is r squared theta. Wait a minute. I just realized, did I do this correctly? Is this supposed to be area of sector OCD is actually, I'm wrong. Wait, hold up. This should be y. Oops. Yeah, there you go. A little bit of substitution problem, I think. So did I do it correctly? Yeah, I made a bit of a mistake. So this should be not 2y, it should be y instead. So yeah, my bad. A little bit of a writing error there. But yeah, once you take it out, then you get this, open it up, then you get this. So you can actually take out y squared over 2 cos alpha, and yeah, you can rewrite as the equation that they want you to write it as, and you should be able to get the answer. All right, slight mistake on my side, but it's a minor error. All right, so question 10. In the expansion of, okay, this right here, where a and b are constants and a is greater than 0, the term independent of x is this, and the coefficient of x power 6 is this right here, negative 6912. Show that a squared is equal to b equals to a squared, b is equals to negative 12. Find the value of a and the value of b. Okay, so first we need to find what the term independent of x is. So the term independent of x will be this right here, 9c3 a to the power 6 b3, b to the power 3. And the way, okay, it's, I guess the main part of this whole question is, how do you quickly figure out what the combination has to be in order for me to find the term independent of x? So for me, the way I figure it out is, okay, we're given what? Ax plus b over x squared, right? I think the hard part here is not actually solving. The hard part here is figuring out what combination of 9c, let's say r, should I get in order for me to get x to the power 0, right? A term in x to the power 0. So we know that, so for me, if I don't know how to figure it out, it's kind of like a guessing game, or from experience, I kind of just know how to do it immediately. So, okay, we know that this is an x, right? And this is an over x squared. So whatever the value is here has to be twice the, whatever the power of x here, in order for me to get a term independent of x, right? This power here always has to be twice as large as the power here, because this is power of 1 and this is power of 2. So 2 is two times bigger than 1, right? So whatever the power is on this one has to be, whatever the power is on this has to be twice as large as the power of this. And if you're familiar with numbers, you know the number immediately. So between 0 to 9, what are the combination of values I can get? There's a lot, right? There's like 0, 9, then there's 1, 8, 2, 7, 3, 6, right? If you're familiar with numbers, you immediately kind of just know what numbers to use. In this case, this has to be 6, and this has to be 3, right? Because why? 1 times 6 is equals to 6, and 3 times 2 is going to be equals to 6. And x to the power 6 over x to the power 6, when you divide, it's just going to be x to the power 0. It's just nothing, So, yeah, that's how you quickly figure it out, how to find the term independent of x. And once you figure that out, if you don't know, you can just, do it linearly, like 1 by 1, 0 to 9, and trial and error it. But if you're familiar with numbers and multiplication, you should be able to immediately find out the number. So if you find out the term independent of x, we found it, that's going to be this. So all you need to do left is just rearrange it, and you can get this. And you can just show it immediately. Easy. All right. So same thing with the term in coefficient of x to the power of 6. So it's the same thing. You have to be familiar with numbers. Same idea, So it's just like 9CR AX. Ask yourself, what number can I get? What number multiplied by this will give me x to the power of 6? When you were given x and x squared, 1 over x squared. So in this case, it's going to be, this must be 8, and this must be 1, right? Why? Because x to the power 8, x to the power 2, divided by x to the power 2, it gives you x to the power 6, which is what we want. So yeah, that's going to be the number that you want to use. So it's kind of just like guessing, but at the same time it's not if you're familiar with numbers. But if you don't know, you can just, try and error it. Just do it slowly. Take your time. You have 2 hours for this paper. You should have enough time. So once you figure it out, open it up, rearrange it, and you notice that, okay, you get this right here. So what you need to do next is really just split it open, It's actually x to the power 6, and if you split it open in 2 parts, it's going to be x to the power a to the power 6, and a squared multiplied by b. And a squared multiplied by b, we know it's negative 12. So substitute that in and rearrange it, and you can get a equals to 2. Then find b, So this substituted in, you get 4, divide, b equals to negative 3. And that's how you get the answer. So 7 marks. This part might slow you down because you don't know what the combination is. So yeah, you could try and error it, or trial and error, or just play the guessing game, or if you're familiar with numbers, you can immediately find it. Alright, so last question, finally. The line with equation, so the line with this equation, with k as a positive constant, is a tangent to the curve with the equation of this. So find the value of k, and hence find the coordinates of the point where the line touches the curve. So there's two methods, one using x substitution or y substitution. The best method here is to use x substitution, because y substitution is kind of long. So this is you just have to find, first you have to find what the, we need to find what the value of k is, and then we find what the coordinates of the point of, intersection is. So since, by reading the question, the line L, let's say the line is L, the line L is a tangent to the curve. That means it intersects the curve at one particular point. So this implies that the discriminant is equal to 0. When you equate both the line and the curve together, the discriminant is equal to 0. So the reason is because it's a tangent, and a tangent implies that there's going to be one intersection point, right? Because if you have a curve like this, a tangent is going to be like this. Oh, that's not a good line. Like this. So at one point of intersection, the line will touch the curve. So the discriminant is going to be equal to 0. And that's what I did. So first we have to substitute it in, rearrange x plus 3y equal k to it being in terms of y, and then label them and substitute them in. Once you substitute, rearrange it, you state that the line is a tangent to the curve, and so this implies one intersection point, which I defined as P, and we know that since it's a tangent, the discriminant is going to be equals to 0. So b squared minus 4ac equals 0, blah blah blah, rearrange, a lot of algebra, and you get, once you simplify, you get this right here, k squared plus 6k minus 91. Factorize it, and you get two values of k, which is 7 and negative 13. But, they mentioned that k is a positive constant, so that means k equals negative 13 must be rejected. So that's what I said, k is greater than 0, so k must be equal to 7 only. This implies that k equals 7 only. So using k, we substitute k into equation 3, because 3 is the equation when we substitute both 1 and 2 inside of each other to find the intersection point. So we can just immediately use k and substitute into equation 3. And so simplify it, you get this quadratic. Simplify it, factorize it further, you get y minus 2. So the repeated root, so y equals 2 is the only point. Sub y equal 2 into 1, and you get x equals 1. So p is 1, 2. 1 being the straight line equation. You could substitute it into 2 or 3, but 1 is the easiest because it's a simple equation. So the other method is just using y substitution. So it's really the same way to do it, but instead of using it in terms of y, I did it in terms of x. I just wanted to show that both ways work. So yeah, same idea. So now you just substitute y into 2, 1 equals 1 into 2 again, but this time you substitute into these two instead of the x, which is more complicated, but it's still doable. So, rearrange it, you get equation 3 right here, and I state the same thing again. Line is a tangent, so one intersection point defined as p, discriminant. So we know the discriminant is going to be equal to 0 because it's a tangent. So b squared minus 4ac equals 0, same thing. Yada yada yada, and you get this right here, the quadratic, and k minus 7, k plus 13, same thing. K is a positive constant, right? So reject negative 13, and you get k equals to 7 only. So same idea, using k, sub k into 3, and yeah, you find x. So same idea, so x squared minus 2x plus 1, once you rearrange it and simplify it, and so when you factorize it, x minus 1 squared, so that means x is equals to 1. And substitute x back, x equal 1 into equation 1, and you get y equals to 2. And so p is 1, 2. So yeah, same way to do it. Same idea. It's just that one is more easier than the other. I would recommend doing both if you have the time. If you don't, choose the one that's easier for you. For me, I would choose 1 as the easier method, but you could use 2 as well. All right, so that's it for the paper. Thank you for watching this video. I hope you can subscribe and hopefully like the video. I know my explanation might sound a little bit choppy. I'm still, relatively new to this YouTube, explanation thing. I've been trying it out. I want to share my ideas, to fellow students taking the IGCSE exam, because when I was a student, I didn't really have, the opportunity to study alongside with a good teacher. So everything I did here is just based off my own research in additional mathematics all by myself. Everything I discovered here is what I discovered as a student when I did IGCSE. So if there's anything that you don't understand in this whole paper, just ask it in the comments. I'll reply to it as soon as possible, I promise. And yeah, I hope everyone here has a great day, and see you on the next video. Bye.